So, meron tayo doon na intermediate pressure or dati tinatawag na high pressure turbine and low pressure turbine. So, we move on now to the nawala yung internet. Ayan. So, ayan. 39. Anyway, class, so, yung iba, balik na lang sila dito. Ayun, mag-in. Okay? So, sa reheat yun, class, ha? So, dalawa lang yung turbine doon. Dalawa yung turbine natin sa reheat cycle. Same as with the basic simple Rankine cycle. Ang dinagdag doon is another turbine and a reheater. Kaya siya tinawag na reheat Rankine cycle. We move on now to the, just share my screen. Ayan. Can you just share them? Ayan, notes. Yun niya mag-view. Ayan. So, dito na tayo sa regenerative cycle. So, ang regenerative cycle, class, if the reheat has 2 turbines, dito, in a regenerative cycle, we have a boiler as well as turbine. Papasok na dito, class, yung tinatawag na open feed water heater and the closed feed water heater. Okay? Kung sa reheat cycle, palaging 1 kilogram mass ang entering in each components of the cycle or each part of the cycle. Dito, class, may tinatawag na tayong fraction of steam extracted. Okay? Papasok na yung M natin dito. Okay? Yung mass natin, leaving the turbine that is going to the open or the closed feed water heater. Dito yan, class. Dito, sa open feed water heater. And yung some part is entering the turbine. Okay. So, bakit nga ba kailangan natin ng regenerative Rankine cycle? Okay. So, we raise the temperature of the liquid leaving the pump. Yan. Itong pump number 2 natin sa figure. So, this is just an example of a regenerative cycle wherein this is an open heater. Take note, open heater. So, yan muna yung pinakita ni ma'am kasi mas madali yung TS diagram ng open heater. Okay. Balik tayo dito sa schematic. So, kailangan natin ng regeneration dito kasi we need to transfer heat to the feed water from expanding steam in a counterflow heat exchanger built in the turbine. Okay? So, ang tinatawag dito, class, yung practical regeneration process wherein in all steam power plants, ini-extract natin or the extracting or bleeding na tinatawag. Yan na, baka ano yung naisip nyo. Extracting or bleeding steam from the turbine at various points. So, dito yan, class, from this turbine, sa turbine natin, hindi ko na susum. Hindi pala ito PDF. Okay. So, yan, sa turbina natin. So, we need to produce more work by expanding further in the turbine. So, we use to heat the feed water instead. Okay? Yung feed water dito kasi sabi ko, from the turbine, high pressure, high pa din yung steam natin. So, mainit pa yung temperature din natin, higher temperature. Nangyayari sa turbine natin. So, ginawa itong device, or yan na tinatawag nating feed water, is heated by regeneration. Yan. Regeneration yan, class. Ang tawag na dyan is the regenerator or yung feed water heater natin. Okay? Regenerator or feed water heater. Or makikita nyo sa mga symbol, yung feed water heater natin is always FWH. Okay. So yung regeneration class, it doesn't only improve cycle efficiency, but it provides a convenient means of derating the feed water, or tinatawag natin removing the air that leaks in the condenser. Okay? Dito class sa condenser natin ha. Di ba sa simple Rankine cycle natin, we have the boiler, turbine, condenser, and the pump. Dito, dagdag na tayo ng dalawang pump. Okay. So, ano nga ba class ang open feed water heater? Yan. An open feed water heater is basically a mixing chamber. Yan. Direct contact yan class ha. Where the steam extracted from the turbine, dito class ha, from turbine, we have number 2 and we have a mass of M considered. So that is now stream extracted. And it mixes with the feed water galing dito sa pump 1 natin. Ayan. So this is now your open feed water heater. So sa process class, ulitin ko lang, from the boiler, the steam is heated at a higher pressure that will cause our turbine to generate electricity, or the turbine shafting to move, that is connected to a generator wherein we can now produce the work of the turbine. After that, the steam is extracted at some portion is extracted to the open feed water heater, and some of it is extracted to going to the condenser. So take note, the entering mass at turbine is 1. And while the mass leaving the turbine on that is going to open feed water is considered as letter M, or denoted as M, mass of steam, and the mass of the steam going to the condenser is considered as 1 minus M, or denoted as 1 minus M. After that, yung condenser natin is connected to a pump. Yan, same pa rin class dito yung ano natin ha, yung mass from 4 to 5. After that, papasok na dito sa feed water. So sa feed water, since this is an open feed water, magmi-mix ulit yung na-extract nating turbine, na-extract nating mass sa turbine. Okay? Magmi-mix ulit sila dito sa open feed water, so balik ulit siya sa 1 kilogram. Considering na 1 kilogram mass yung mass natin. Okay? And going back to the boiler. So, dapat alam niyo na yung processes natin dito ha. Or energy balance during the cycle. Ayan. So, this is now the TS diagram. As you can see, from process 7 to 1, that is the boiler. Dito yung class, nakalimutan ko yung 1. Ayan, sulat natin dito yung 1 kilogram mass entering. So, this is 1. Ayan. Considering that is a 1 kilogram mass. Okay? So, after that, dyan ka na sa 1 kilogram mass. Entering process 1 to 3, nangyayari na dito kasi yung sabi ko nga, pumupunta sa open feed water. So, denoted as 2 to 6 is where your feed water, and 3 to 4 is the condenser. Yan. Sulatan natin para hindi kayo malito. So, 4 to 5, babasahan nyo to dito class sa schematic diagram natin. 2 to 3 is your yan, separate process wherein yung mass natin papasok sa dito class papasok na yung sa open feed water heater natin. And 3 to 4, yung condenser natin. Bakit class ina-explain ko yung TS diagram and the schematic? Kasi mas maiintindihan nyo yung problem or a certain problem pag kaya nyong i-draw yung schematic and the TS diagram of the process. Not necessarily kung sinabi class sa problem na superheated, kung nalaman natin na superheated yon, pwedeng dito pa yun sa labas. Ganito class. Ayan, considering superheated, ayun, palubat na ba ako? So, pwede din class sa labas. Okay? Pwede yan mangyari na dito yan sa labas. Depending upon the given state points or the given mixture or the given, yes, parameters in the problem. Okay, pwede yan class. Pwedeng mangyaring superheated yung steam natin from 2 to 3. Okay? Mangyayari, if that is 2, paganyan din sila. Considering superheated, 1, 2, and if this is 3, straight muna dyan class, when you draw the TS diagram, under the TS diagram, yung from when it is a constant pressure, pag sa loob pa, straight pa. Pero pag superheated, saka ka mag-slant. Ayan. This is now year 3. So, considering na superheated yung steam natin. And 4 to 5, we have the work of the pump, and 6 to 7. So, we have now pump 1 here. So, ayan. It's pump 1. It's pump 2. Ayan. So, dalawa yung magiging work of the pump natin. And process 7 to 1, yan. Yan yung boiler natin. Ay, wait, class. It's now your boiler. Yan. So, ganyan class pag open feed water, considering yung mass extracted na M, yung M natin, and the 1 minus M. Okay. So, this is now the cycle analysis. Yan. On the basis of a 1 kilogram of throttle steam. Ayan. Yan, class. So, magkakaroon na tayo ng mass balance. Kung dati, energy balance, we have now the mass balance. Okay? Considering, ano tayo? Pupunta tayo doon sa open feed water heater. So, pag open feed water heater lang to class ha. Yan. Mas madali isolve to class na open feed water heater. So, energy balance, entering mass is equal to the mass leaving the system. So, from here, diba class dito sa taas? Ito yung kino-consider natin class ha, ditong part. Ito class na part, the open feed water heater. Yan. Entering natin na mass is the M, ito, plus the 1 minus M is equal to 1 kilogram. Kung yan yung magiging basis natin. Okay. Papasok na class yung energy balance natin. So, all entering energies is equal to all the leaving energies within the system or the component. So, since the consideration now is the feed water heater, yan, we have the MH2 to class, MH2, and plus 1 minus M, H5. So, ito class yung entering natin ha, entering. Ayan, lapit-lapit lang. And the leaving energy now is equal to the 1 kilogram of the enthalpy at 0.6, given yung parameters natin. Okay, simplification, we have now the mass of the bleed steam. And this is now the mass of the... Kasi sabi ko nga, that is either extracted or bleed. So, yung regeneration process natin in steam power plant is accomplished by extracting or bleeding the steam from the turbine at various points. So, this is now the mass of the bleed steam. Okay? So, yan muna kasi yung hahanapin kadalasan when the process is undergoing a regenerative process or regenerative Rankine cycle. Okay? So, the heat supplied now, considering 1 kilogram, so equal naman siya class in the boiler. So, H1 minus H7, energy balance lang. In the turbine work, ayan na, malami-lami. So, considering yung 1 kilogram natin, Highlight na lang tayo. Okay? In a 1 kilogram, so entering natin from the turbine, we have 1 kilogram. Ayan. This is now our consideration. And the the extracted and the bleeded steam, we have the MH2 and the 1 minus H plus 2. And the energy leaving the system, we have now the work of the turbine. And simplification, the work of the turbine now is equal to H1 minus MH2 minus H1 MH2 minus 1 minus MH3. Yan. So, distributive property, 1 minus H3. Negative times negative, positive na yung magiging MH3 natin. So, we have now H1 minus H3. Ito na, class. And the M now is factor out mo muna. So, kinuha yan dito. MH2 and the MH3. This is now addition. Okay? Ayan. Bakit mo may ganyan? Take note, the work of the turbine. Pwede naman to, class. Pwede naman to. We can go for that. But since in the, sabi dito, or. Ano to, class na or? So we have now H1. Naririnig ka, class. H1 minus MH2. Ayan. So, binalikan ko lang dito sa taas, class. Yan. Yung asterisk natin. Palitan natin yung color. Ayan. Good morning, sir. So, H1 minus MH2. So, binalikan doon sa taas. Minus 1 minus MH3, the quantity. So, we infuse this, the H2. Ayan, class. The H2 minus H2. So, this is just considered as 1, di ba? I mean 0. Di ba, class? Naintindihan nyo? In-infuse lang natin to dito sa equation. Ito. To make necessary adjustment. Ayan. So, nilagay siya dyan, class. So, kinonsider yung 1 minus H2. Dito na. And M, H2 plus H2. Ayan. Makakancel lang naman yan, class. So, 1 minus M. 1 minus the quantity, 1 minus MH3. Yan. Proper. Finactor lang to, class. Na ito, na part. Ito na siya. So, karoon na ng 1 minus MH2. Ayan. So, we can make use also this equation, derived equation. Ayan na. So, galing siya dito, yung H2 and H3 natin, 1 minus M. And ang i-consider lang natin dito is yung H1 and H3. So, we can use both equation kung alin kung saan kayo mas convenient. Or, in the problem, what is the given mass of the bleed steam? Okay. So, this is the derivation of turbine work. And in the heat rejected, since meron na tayong extracted steam, so this is now 1 minus M. Energy equation, we have now entering the 1 minus MH3, which is equal to the leaving the heat rejected at the condenser as well as the same bleed steam or the 1 minus M times the enthalpy at 0.4. So this is now the heat rejected. We have 1 minus M, H3 minus H4. Okay? Ayan, H3. We move on to the total power pump. Total pump work. Okay. Sabi ko kanina, Regenerative, we have two pumps. Yan, we have pump at point 1. So from the condenser to the open feed water, that is the pump wherein the pump 1 is located. And after the open feed water to the boiler, we have another pump located. Okay, so the total pump work now is this one. So we have the summation of the pump work from point 1 to pump at point at the first location, the pump at second location. So we make always use of the approximation of the work of the pump, wherein the specific volume saturated liquid is always multiplied by the pressure at certain point, or the pressure from the open feed water to the condenser. And the work at pump 2 will make use of the specific volume at saturated liquid that is multiplied also to the pressure at the boiler minus the pressure at the open feed water heater. Okay? So this is the equation that is usually used, but since this is an approximation, yan, ito po class yung ginagamit kadalasan sa pag-compute when computing for the total pump work or the any given regenerative Rankine cycle. So the summation of the work of the pump, to make gagamitin na natin to. So sa TS diagram natin, ano yung pump natin ditong part. Okay, so this is now your sa feed water heater. Ayan. Ayan, dalawa yan sa boiler. So this is from the condenser. Ito yung sa boiler natin. So this is 0.7, this is 0.6, and this is tama ba? 5, 4, 4. So this is 5 and this is 4. So the approximation now of the total pump work. So hindi na tayo magdadalawa-dalawa pang i-compute. So gagamitin na natin is from condenser to the boiler. Okay? So ito na yung hinahanap natin. We have now the saturated liquid. I mean the specific volume at the saturated liquid multiplied by the pressure at the boiler. So boiler to class minus pressure sa pump natin or the first pump. Okay? Yan. Kung ano yung nangyayari doon kasi constant pressure naman nangyayari. So that is the pressure also from the condenser. Okay? So that is now the approximate total pump work in a regenerative Rankine cycle. And using the necessary equation or from equation derived from the work of the pump and the total pump work, we can make use now of the total or the work net in the system. May kulang akong nasulat. So, minus work summation ng work ng pump. Class pakitingnan na dun sa PDF na nasend ko. May kulang. So, this is work net. So, ito yung ginamit na equation natin from the work of the turbine H1 minus H2 plus the 1 minus M H2 minus H3 minus the quantity or minus the summation or the approximate total pump work. Ito. Kulang to class dun sa nabigay ko. Ayan. And finding for the thermal efficiency, we make use of the work net over the heat added. So, pwede naman to class na 1 minus the QR over the QA. Ayan. Kasi once na dinerive mo naman siya, mag-equate lang naman to. Okay? Pero ito kadalasan ginagamit natin. Ayan. Work net over the heat added. So, sa heat added natin, sa boiler lang yun nangyayari. Okay? So this is the derivation on an open or in a given open feed water heater. So ito yung kadalasan hinahanap, what is the mass of the bleed steam. When we say the bleed steam, it is located at the open feed water. Okay? The energy equation or the energy balance that is needed to solve for the problem, the given problem, in a regenerative cycle is always located at the open feed water heater. Take note, pwedeng maging superheated yung point 2 natin and point 3 depending upon the given state points. Okay? Excuse me. Okay. So this is now the open feed water heater. Okay? Punta tayo dun sa closed feed water heater. So, if the open feed water is not complicated, kasi ang open feed water heater natin is basically a mixing chamber where the steam extracted from the turbine mixes. Ayan, dito sa open feed water. So, it mixes with the feed water exiting the pump. So, that is the first consideration in an open feed water heater. Yan, so makukompute natin yung mass of the bleed steam. So, naintindihan ba kas yung open feed water heater? Raise your hands if you do. Or if you do not, it's okay. Just ask ma'am. Okay. So, ganun po class sa regenerative cycle. Yan, thank you. Thank you. Noted. Everyone raise their hands. So, that is an open feed water heater. Sabi ko nga, dito sa Thermo2, as long as you double check the given problem, kung sa given pala mali na yung nasulat mo, mali na lahat kasi cycle siya. So, when you compute for the cycle efficiency, automatically, mamamali ka na. Considering that yung regenerative cycle natin is how many points? State points, we have 7. We move on to the closed feed water heater. Ayan. Screenshot ko lang. So, we move on to the closed feed water heater. Ayan. Hanapin ko muna class. So, while waiting, answeran nyo na class yung sa regenerative. Ayan. Nasaan na yung problem dito? Masyadong complicated to na binigay ni ma'am siya. Ayan. So, this is class a computation wherein given na sa atin yung, hanapin ko lang, 10.46. Assign ko yung problem. So, papasok na dito class sa closed feed water heater natin Madami-dami yan. 10.46. 45. Ayan. So, a steam power plant operates on an ideal regenerative cycle. So, steam enters at 6 megapascal and 450 degrees Celsius and is condensed in the condenser temperature at 20 kilopascal. So, kinonvert ko na dyan class yung 20 kilopascal into MPa, which is 0.02 MPa. Yan. Assuming that the feed water leaves the heater at the condensation temperature. Yan, madami po siya. Of the extracted steam, and the extracted steam leaves the heater as a saturated liquid and is pumped to the line carrying the feed water. Ayan. So, mahaba-haba to. So, what is now, the steam is extracted from the turbine at 0.04 MPa. Ayan. So, hinapanat dito yung network output per kilogram mass of steam flowing through the boiler in the thermal efficiency of the cycle. Ayan. So, we have, ano yung parts na meron dito sa feed water natin? So, mamaya na yung mga numerical. Dito muna tayo sa schematic diagram of a closed feed water heater or the closed FWH. Okay. So, this is another type of feed water heater that is frequently used in steam power plants. Yan, na closed feed water heater natin. Kung kanina open feed water heater, so ngayon, closed. Basically, dito sa closed feed water heater, the heat is transferred from the extracted steam to the feed water without, take note, without any mixing taking place. So, anong pinagkaiba? Sa closed feed water heater, there is no mixing, while in a open feed water heater, meron nangyayaring mixing of the steam or the two streams. Okay. So, yung two streams natin, ayan na, makikita niyo yung 1 minus m dito sa 5. 1 minus m pa din dito, class. Ayan, makita natin. So, take note, 1 minus m natin dito, class. This 1 minus m. So, yung two streams natin now can be at different pressures. Ayan. Since they do not mix in a closed feed water heater, hindi sila nag-mix. So, from 0.5 to 0.9, hindi siya naapektuhan ng 2 to 6. Ayan. Same pa rin yung stream natin or the mass entering from 0.2 to 6 and entering from 5 to 9. Anong tawag dito, ma'am, sa 7, 8, 9? Ang tawag po dyan, class, is the mixing chamber. Ito na po. Kung kanina, we have an open feed water. Ito, class, pag sa closed feed water, saka pa lang, after leaving the closed feed water, saka pa lang sila mag-mix dito sa tinatawag na mixing chamber. Ito, class, yung mixing chamber natin. Okay? So, that is now we're in yung anong dinagdag dito, class? Dinagdag dito si mixing chamber compared to the open feed water heater. So, same pumps. We have two pumps from the condenser and from the closed feed water heater. Yan. This is the basic schematic diagram of a closed feed water heater. Ayan. How about the TS diagram? Same lang, class, but maduduling ka lang dito. Kung kanina, draw ko lang dito sa kabila, kung magiging open feed water heater to. Diba? Direkta lang, class. Pag ganito. Ditong part, ganito. Ayan. From 4, 5, 6, 7, papunta na to sa boiler. Ayan. Point 1. Ito. Point 2. Considering saturated liquid. Point 3. So, dito, class, nagkakaroon na ng mixing chamber. So, from process 5 to 7, ayan. Hindi na siya, class, dito sa, pumunta dito, sa schematic, di na siya dumaan dito. Kung kanina, pupunta pa siya dito sa 6, eto, direkta na, class, kasi hindi naman sila nag-mix, diba? in a closed feed water heater, hindi naman sila nag-mix. Automatically, doon sila mag-mix sa taas. Ayan. Magulo, ma'am. Ayan. From 4, 5, 6, di ba? Dito, class. From process 4 to 5, pupunta sa 9. So, dito lang pupunta sa 9. Ayan. Diyan sa gitna niya. After that, si 6 to 7, magmi-mix na sila. Babalik siya dito, class. Pabalik siya dito sa gitna para mag-mix. After that, punta na doon sa boiler. Boiler natin. Kasi same pressure naman. Okay? So, paano na yung pagsosolve natin? What is now the process in solving a closed feed water heater? Yung pinakauna natin, the given in the problem is 6 megapascal and temperature 450 degrees Celsius. Using the steam table, this falls under the superheated. We have now the H1 and the entropy at point 1. So, kinuha lang natin yung necessary or the needed state points. Ayan, walang internet. Ayan. Balikan natin. So, the pressure 1 is given as 6 MPa and the temperature 1 is 450. So, di ko na i-explain pa. I mean, babalikan ko pa ba kung bakit siya superheated. So, that is now your state points or the properties at point 1. We have the enthalpy at point 1 and the entropy at point 1. From process 1 to 3 class, take note that is a constant or tinatawag nating isentropic process. So, S1 is equal to S2 which is equal to S3. Since from point 2, excuse me class, yung point 2 natin class papuntang feed water heater. So, S1 is equal to S2. Finding the quality at point 2, we have 96.55. And given sa atin yung feed water entering pressure, which is 0.4 MPa. So, kukunin natin enthalpy at point 2. So, nakuha na natin 2,664.92 kJ per kilogram. So, makuha natin to using the first solving the quality of the steam at the given. Using the given sa atin yung S1, sabi ko nga constant yung entropy natin. So, from process 1 to 2, it will undergo a constant or the isentropic process. Okay? So, we have now the pressure at point 1 and the pressure at point 2. Okay. After that, yung pa-point 3 class is a condenser. Babalikan nyo ito dito sa schematic diagram natin. Ano yung point 3 natin? Pa-condenser. Ayan. Since the pressure is given in 20 kilopascal in the problem, convert it into MPa. Okay, you convert it into MPa. After that, sabi ko nga, isentropic process from process 1 to 3. Yan. We have S1 equal to S2, which is equal to S3. Yan. Paano natin mako-consider that it falls under the wet region? Sabi ko nga, if the given, pag ang given natin class, yung S natin is less than sa SG natin, automatically nagpo-fall yan sa wet region. Pero kung yung S natin na nakuha is greater than, superheated yan. Okay, superheated vapor. Okay. From pressure 3, we have 0.02 MPa. So that is now a constant isentropic. Yes, tama. Isentropic process. So, this falls under the category of the wet region again. So, hanapin mo yung quality at point 3. We can now find the enthalpy at point 3, which is now equal to 2,213.26 kilojoule per kilogram. So, check na yung point 1, point 2 natin, point 3. Now, we move on now to the pressure or the work of the pump using the approximation. Okay? Approximate pump work. Alam natin that process 3 to 4, ano yung process 3 to 4 natin? That is from the condenser. So, constant pressure nangyayari dyan, class, 3 to 4. So, 0.02 MPa. Alam natin from 0.3 to 0.4, yung H4 natin. Paano nakuha natin yung H4? That is ito ba, class? Tangit ang pansulat. Ayan. Ito baga, class, since constant yung pressure test sa 3 and 4, this is H3. Tapos, ayan. Excuse me. Okay. Pasensya na, pas nag-run out po dito sa buseng. Let me continue. Okay. Okay, class. Let me continue. Ayan. Ayan. Let me continue. Saan na tayo? Okay, since this is now the... Ayan, balik tayo. So, in process 3 to 4, we all know that is a constant pressure or isobaric process. So, HF3. So, this is now a constant. Ayan. Constant yung pressure natin. So, baliktad. And this is equal to PF3. Okay? So, be given sa atin yung condenser pressure natin. Makukuha na natin using the steam table. These values. Ayan. Sabi dito, yung pressure at 0.5. Ayan. Pressure at 0.5, pressure at 0.10, pressure at 0.8, pressure at 0.7, and pressure at 0.1 is equal to 6 MPa. Ayan. Dito yung class, 5, 9, 8, 7. So, constant yung pressure natin, which is equal to 6 megapascal. Sabi ko kanina, in In an open feed water heater, we make use of the approximate pump work of the two differences, or the two pump, or the from the condenser to the pressure at the condenser to the pressure at the boiler. While here in an open feed water heater, we compute for the different pump work in each process. Okay? Since we have the point 1, so sa condenser baga class, from the condenser to the closed feed water heater, yun yung first pump work natin. So this is now your pressure at the condenser and the pressure at the feed water heater. Okay, the P5. So, using the 6 MPa and the given pressure at point 4, 0.02 megapascal, we have now the pump work at, wait, wait class. Ayan. So, balik tayo dito class. So, we have the pump work, we have 6.0289. From the pump work at the first class, so we compute again for the enthalpy leaving the pump. Diba? Yung H5 natin. Dito yung class. Ito. H5. So, para hindi kayo malito class, for you to simply solve this, para mas madali, i-draw nyo class para mas maintindihan. So, this is from condenser, yung 4, yung pump natin, leaving is 5. Yan. Para makuha natin yung H5 natin. So, this one class, makukuha na natin using or computing for the enthalpy at point 5. And for the work at pump 2, yan. Ano naman yung gagamitin natin class? Yung specific volume at saturated liquid at point 2, if that is just equal to the specific volume at point 6. Dito class. This is VF2. Ito class. Dito. Ayan. Equal lang siya sa specific volume at 0.6. So, the pressure now, yung gagamitin natin is from the pressure entering the closed feed water heater, which is 0.4 MPa in the pressure at the boiler. So, makukuha na natin yung work, the pump work at 0.2, which is 6.0682 kilojoule per kilo. That is now the work of the pump at 0.2. In solving for the specific or the enthalpy at 0.7, so from the pump again, if you cannot, ayaw niyang balikan, ito galing to sa feed water. This is now noted as, so this is a closed feed water heater. Ayan, balikan niyo dito. 6 and 7. Ayan, 6 and the leaving is 7. So, nakuha na natin yung enthalpy at 0.6. Hanapin natin yung enthalpy at 0.7. So, i-add lang natin na compute natin ang work of the pump. We have now H7. Ayan. Paano naman daw yung H8 and the H9? Ayan. Ito na yung magiging big question natin. The H8 and the H9, usually, if given the problem, usually, ito dapat yung formula na class in solving for the given enthalpy H8 and H9. Yan. Yan yung mga approximation natin para lang siyang ina-add yung certain work of the pump at a given pressure and the enthalpy at entering, which is 0.6. So, nakikita niyo naman ang figure from 0.6 to 0.7 and ayan, yung scattered lines natin or your dotted line natin from 0.6 to 0.8 at from 0.6 to 0.9. Since this is a mixing chamber, yan, dito class, ito, mixing chamber siya. So, pag mixing chamber class, automatically, when it falls or when two streams or two fluid streams are being mixed, nawala yung internet ko. Nawala ba yung share screen ko dyan, class? Bakit
Yes
nawala?
po, ma'am.
Nawala ba, class?
Yes, ma'am.
Po?
Yes po, ma'am. Wala po, ma'am.
Hindi ko kayo naririnig. Share screen. Oh, ayan. Mabuti na lang at may laptop ako dito katabi. Nakikita ko kung sharing ba ako o hindi. Okay. Sa Gmeet natin. Class, naririnig ba ako? Naririnig ba ako?
Yes,
Yes
po.
po, ma'am.
Yes or no?
Yes po,
Naririnig
ma'am.
po.
Ayan. Okay na. Akala ko hindi. Ayan. So, balik tayo dito. So, since this is a mixing chamber, the definition or the properties or the working description of a mixing chamber. When two fluid streams are being mixed, so, same yung enthalpy natin. Ayan. Same enthalpy. So, we denote as H7 is just equal to the enthalpy at point 8 and enthalpy at point 9. Okay? Excuse me. So, using that, we have now H7, which is equal to H8 and H9. Okay, take note of the mixing chamber. Excuse me. So, eto na question. Mahirap-hirap. And finding the energy balance at the closed feed water heater. Yan, magulo-gulo. So, dito muna tayo sa schematic diagram. Yan. Ano yung entering natin? MH2, the mass times the enthalpy at point 2. Ayan, highlight ko. So, entering MH2 plus 1 minus M from the first pump equal siya sa leaving, which is MH6 and the 1 minus M, H9. So, this is a closed feed water heater. Simplifying, we have MH2 minus MH6 equal to the 1 times M. So, ito class, you have this, the H9 minus the H5 in your algebra. So, kukunin natin yung extracted steam natin from the turbine. So, simplification, ayan class, yung M natin nilabas. And yung isa pang M. Bakit? Kasi kailangan natin siyang masolve. Using the equation, M is equal to H9 minus H5 all over H2 minus H6 plus the H9 minus H5. So, solving for the mass of or the fraction of the steam extracted from the turbine, yung H9 natin, nakuha na natin ha, and the H5. The different properties, nakuha na natin, H2, H6, H9, H5. So, we have now the mass of the extracted steam. The fraction of the steam extracted from the turbine, we have 0. Excuse me. 0.1464. Okay. So that is now the mass. And the heat added in the boiler, sabi ko nga, wala pa naman on the basis of 1 kilogram mass. So, 1 times, ano lang to class? So, we have 260.99 kilojoule per kilogram. And the mass extracted, or in the condenser class, we all know that the mass bleeded or the extracted mass of steam is 1 minus M. So 1 minus the 0.1464 times the H3 minus H4, we have now the heat rejected and heat rejected, heat added. And finding for the work net. Kung kanina class, we can make use of sa equation ni ma'am, we can make use of the work of the turbine minus summation of the work of the pump. Pwede naman class in finding the work net. This is another way of computing. Work net is equal to the heat added minus the heat rejected. Okay? So this is now the work net, the 10,000 or 1,016.3398 kilojoule per kilogram mass. Bakit ma'am hindi mo ginamit yung work ng turbine? Mahaba-haba yung equation natin sa turbine, di ba? Yung dinerive natin last time. So we make use of the heat added minus the heat rejected. Naintindihan ba? Di ba, pinakita ko sa inyo yung pag-derive ng work ng turbine? It is easier to solve the heat added and the heat rejected. Hahanapin mo lang si extracted mass. Same with the work of the turbine, hahanapin mo to. Pero mas madali nga lang tong work net and the heat added minus the heat rejected. Okay? So, yan. We have now the work net. Considered naman siya work net. And finding the thermal efficiency, ito naman class. And kasi yung work net natin, equal naman siya sa heat added. Yung work net natin, heat added minus the heat rejected over the QA. So, ito na, QA over QA minus QR over QA. So, the thermal efficiency now can be used as 1 minus the heat rejected over the QA. Yan. So, this is now the thermal efficiency in a regenerative Rankine cycle. Ayan. Dinerive ni ma'am para makita niyo. Okay, so pwede po yun class. In a regenerative cycle, kadalasan ang hinahanap na natin ng work net is the heat added from the boiler and the heat rejected. So, yun na class, yung simplification. Pero pag pinahanap ko sa inyo yung work of the turbine, you will make use of the equation that was derived on the feed water heater. Kasi same lang naman yun, class. Same yung magiging equation mo sa open feed water. Kasi dun pa siya sa taas, di ba? Magva-vary lang sila dito sa properties at dito. Dito lang sila magva-vary. Sa closed, sa points 2569. So, dyan lang magva-vary yung open feed. Sa open feed water, yung closed feed water heater. Okay? Kung sa turbine, kung ano yung na-derive natin na equation, yun yung class yung hahanapin natin, di ba? Ayan. Yun class yung hahanapin natin pag sinabi kong open feed water to. Okay? So, ayan. Sa una class, pag na-solve na, madali yan. Kasi nakikita mo na yung pasunod-sunod. Pero pag ikaw na, mahirap na yan. Kaya, you need to practice a lot. I mean, you need to practice more in solving regenerative Rankine cycle. Okay? So, yun class yung ideal regenerative Rankine cycle. Lalo na kung lalagyan ko pa to ng actual regenerative cycle. And, mahirap ba class? And, stop screen ko na. I'm showing. And, okay. So, that is now the feed water or the open, how do you call that? The ideal regenerative Rankine cycle. Okay, class. So, may katanungan ba, class? Siyempre, wala pa kasi wala pa na ako pinapasol. Nakuha niyo yung sa reheat? Reheat Rankine cycle, class? Nakuha niyo po? Madali lang yan, class. Nakuha niyo yung exercise ni ma'am? Yes or no, class?